Okay, so in this question you had to use a table given where you're given the number of entries in the box. So what this tells you is that at 8 p.m. there's a total of 23 entries in the box. At 2 p.m. there's 4 entries in the box. So 23 is going to be the total number of entries in the box at 8 p.m. when you stop collecting them. In part A, you have to approximate the rate, which is the derivative, in hundreds of entries per hour times 6. So what this should tell you is that you're looking for the derivative at 6, and now if you look at your table, you notice that there's no 6 in the table, so this is your secant line approximation. So what we're going to do is we're going to use the 5 and the 7 to approximate. So I'm going to enter a new equation. So I'm approximating the derivative at 6, and I'm approximating, so instead of equal sign, I'm going to use the approximate symbol. This is going to be a fraction, so you would use the fraction template. And we're going to do rise over run. So we're going to use the number of entries at 7 minus number of entries at 5 over the run, which is 7 minus 5. And then I'm going to actually get the numbers from the table. And then I'm going to do fraction again. So at 7 it is 21, and at 5 it's going to be 13 over 7 minus 5. And my answer is going to be 4. Now it's either you're going to write 4 hundreds of entries per hour, or you can also say 400 as a number. So I'm going to be consistent with the question. I'm going to say 4 hundreds entries per hour. And I can't spell, so either one. Okay. So this is going to be your answer. Now this is only worth 1 point. So this is 1 point, and you're given the 1 point for the answer. However, in order to get that 1 point, you had to show the computation that led to your score. If you did not show this particular part, you're not going to be given any points. So make sure that if it asks you specifically to show the computations, you're going to show the computations. In part B, you have to use the trapezoidal sum for the 4 subintervals to find this value. So you are basically approximating this right here, and when you answer in the questions in the Google document, feel free to copy and paste what I already have there, because you don't have to retype it. So we're basically going to be approximating, so I'm using approximate symbol again. I have a fraction 1 over 8, and then what I'm also going to do is I'm going to enter another fraction of 1/2. When you're calculating area of a trapezoid, remember it was base 1 plus base 2 over 2 times the height, so the 1/2 as a fraction is going to come up in every calculation, so we can actually factor it out. So and then we need to basically add up all the heights times base 1 plus base 2. So the height for the first trapezoid is 2, and you're basically going to add up the 2 heights together. So it's going to be 0 plus 4. And then my next trapezoid has a height of 3. So it's 3, and then my 2 bases are going to be 4 and 13. My next trapezoid has a height of 2, and my 2 bases are going to be 13 and 21. And my last trapezoid has a height of 1, and my 2 bases are 21 and 23. And this is where you're going to just use your calculator, and no need to show the steps in between. They're looking for the setup, so they're looking for these numbers here. You also could have done e of 0 plus e of 2, and then just get the answer that way, but this is a little easier. So you would write this as an answer, or also you could have written 10.688. But this is your answer for the trapezoidal sum of the 4 subintervals. Now in the second part of the question, they ask you to explain the meaning. So what you should recognize is this is your average value of the function. So this is average value of E function, or E of t, from 0 to 8. So think of this as the average number of entries in the box, because the function E of t tells you how many entries are in the box. So this particular expression represents the average number of entries in the box between 0 and 8 p.m. So I'm going to copy and paste again. Represents the average number of hundreds of entries in the box between noon and 8 p.m. Okay. So this part question, okay, so how did you get the point? So this part B was worth 3 points. You were getting 1 point for the setup for this trapezoidal sum. You also got 1 answer for the correct answer for the 1/8 of the integral. So this is going to be 2 points right there. And then your explanation is worth 1 point. So together you get a total of 3 points for this part. And C, they're giving you another function, and it says that now you're processing the entries, and it's modeled by the function p of t, and it's between 8 p.m. or 8 and 12. So it's asking you how many entries had not yet been processed by midnight. So what you have to figure out is how many have you processed already. So you could say number of entries processed from 8 p.m. to 12 p.m. or midnight. And you're basically going to integrate the function p of t. Now what's nice about this, in the question they gave you the function, so you don't actually have to copy it. So you just say that I'm integrating from 0 to 12, and I'm going to integrate function p of t. You do not have to copy it, it's already given to you in the question, so this is sufficient. And you're going to use your calculator right here. So what I wanted to do here is I wanted to show you how to use your calculator in a most efficient way for this particular question. You're going to be using this function p of t more than once, so the best thing you could do is go into your y equals and type it in, so then you can recall it as y1 and keep reusing it. You don't have to keep retyping it. Just double check that it's actually entered correctly before you start using it. So here's my function, and what I need to do is I need to figure out, I'm going to come back to my question, I need to integrate from, and this is actually from 8 p.m., from 8 to 12. So I'll go back to my calculator and I use my integral function, which is right here, number 4. I'm integrating from 8 to 12. And I'm going to recall my function y1 because I already have it typed in. And I get my answer of 16. You don't have to, please, actually not that even you don't have to, please don't use, if this is a calculated question, do not find antiderivative by hand because you can. I know you could. This is a calculated question, so wasting time actually finding the antiderivative is not going to get you any extra points. So please don't waste your time. This is sufficient. So this is number of entries processed from 8 to midnight. So if you look back at the table, in the box you had 23 entries total. So entries not yet processed is going to be 23 that you have in the box minus 16 which are processed, so it's 7, and it's not 7 entries, it's 700 entries. Now this question is worth 2 points. 1 point was for the setup of the integral right here, and then 1 point was for the answer here, and I keep misspelling entries. Okay. Again, please write as little as possible, so this is sufficient. You don't have to recopy anything down. In part D, this is the last question. It says, according to the model from part C, at what time were the entries being processed most quickly. What you need to recognize when you read this is that they're asking you for the absolute max, and there is a very specific way you have to do it. So you have to find absolute maximum value on the interval. Time enters being processed more quickly. Okay, and it's on the interval from 8 to 12. And remember, in order to find the absolute maximum, what you have to do is you have to first locate all local mins and maxes. We're not going to use the mins, we're just going to use the maxes, but you have to write down that you have to find local relative mins and maxes, and basically you were given a point for considering that you want the derivative of this function to be equal to 0. So this statement right here was actually worth 1 point. Okay, so we need to state that the derivative is 0, that gets us 1 point, and we also need to identify all the critical values. And we have 2 of them, and I got those numbers from the calculator. So in my y1, I have the function p of t. My y2 is the derivative of the function, and if you notice, my equal sign is not highlighted, so we're not going to graph the first one, we're only going to graph the second one. And by using the 0 function of the calculator, I'm only going to do one of them. I can calculate the both zeros. Okay, so this is my one, and there's another one over here. Now the red one is the derivative function. So the derivative is positive here, negative here, and positive. So what this tells you is that at this x value we have a local max, and at this value we have a local min. Since we're looking for the absolute maximum, we only need to consider the local max, which happens to be the 9.18 number. So you could state that you're not considering the local min, you don't actually have to calculate anything, but we do need to calculate the value of p function at both endpoints, so at 8 and 12, and at the local max. And this is where we're going to use our calculator. Remember that we defined p of t as a function y1, so if I go and I simply type in y1 of 8, my calculator is going to give me the value at 8, so that's going to be 0, and that's my answer. And then we're going to do the same thing for the critical number, so we're going to do y1 of 9.183503, which is, okay. Okay, and then our last endpoint is going to be 12. So what you can actually do instead of retyping, on your calculator you can go and highlight and copy, and then come here and change this to a 12 if you don't feel like going back and finding y1. So this is going to be 8. So clearly this is the absolute maximum, and which is what they were being asked for. So then you say you're going to answer, so entries are being processed, I keep misspelling entries, most quickly at time t equals 12. So this was worth another point, and it's an answer and the justification, and this was worth the other point, identifying critical values. So this was worth 3 points total. And that's it. This is going to be the total of 9 points.